Whenever you store energy, there is a chance for that energy to be released in ways you're not intended to use it. That could become a hazard. What has been happening with, in particular, lithium-ion batteries, that they have becoming more powerful. With more energy stored, there are more ways in which things could go wrong. It is important to be able to predict and study the ways in which the energy could be released in an uncontrolled fashion and the potential consequences that can come up with. That might be a fire or simply malfunction of the battery. That will be a more benign. But among the realm of things that could come to happen is the release of a flammable off-gassing that could then ignite and create other hazards. The purpose of this test was to be able to collect data on the strength of the explosion that will come out should an internal cloud develop within a battery energy storage system. We basically test two levels of concentration. We tested an enclosure that was filled with a deficient amount of battery gas. So we injected an amount of gas that was not the optimum. More gas could have been burned with the air that was inside, but we decided to run short. We also run a different treatment. We injected the stoichiometric amount of fuel. That is the optimal amount of fuel that will burn completely. We noticed that the loads that come out of those two situations, when you run fuel deficient or you run a concentration that is the optimum, we noticed that the loads were very different. In one case, when we ran the experiment in lean, it was a very mild consequence, but in turn, when there was enough fuel to burn completely with the air in the enclosure, the blast load was significant. The release of a flammable off-gassing that could then ignite and create other hazards. At BakerRisk, we're particularly well situated to be able to analyze and assess how a hazard could be and design the mitigation measure that will help us stay safe.